So we have an absolute value inequality on the exam 1 review number 7. This comes from section 8.5, so you should practice some of these from 8.5 with both the less than symbol and the greater than. Remember, with the less than symbol, you're going to get a section of the number line that's in the middle, and with a greater than symbol, you get a section of the number line that points to both ends. So with a less than or equal to, you would have had a square bracket instead of a round bracket. Same thing with greater than or equal to, you get a square bracket. Okay, but we're looking at a less than, so we're going to be having this kind of a situation going on. So let's take a look. First, we would get the absolute value by itself. So we'll isolate the absolute value, subtract 2 from both sides. So we'll end up with the absolute value of 3x plus 4 less than 9. And the reason we're getting this situation here is because the numbers whose absolute value are less than 9 are clearly positive numbers like 1, 2, 3, etc. But there could be negative numbers like negative 1, negative 2, negative 3, and so on, until you get up to negative 8. And when you get to negative 9, then you're not going to have absolute value less than 9 anymore. You'll have absolute value equal to 9. And when you get to negative 10, why then the absolute value of negative 10 is just plain bigger than 9. So that's why we're getting this section of the number line between negative 9 and positive 9. So we write that as a compound inequality. The 3x plus 4 has to be between positive 9. Oops, that should be 7, shouldn't it? I bet you were all saying, wait a minute, why didn't she subtract that too? So we have a 7 here. Okay, so we're going to have numbers whose absolute value is less than 7, and that means the numbers will fall between negative 7 and positive 7. And then when you take their absolute value, they come out in between. When you take their absolute value, that absolute value will be smaller than 7. Let's continue to solve now that we've changed over to a compound inequality. We'll subtract 4 from all 3 parts. We're trying to get the x by itself in the middle here. So we have negative 11 less than 3x less than 3. And then divide all 3 parts by 3. So we have negative 11 thirds less than x less than 1. So in interval notation, well, first I'll put it on the number line. Okay, so on the number line, you have the negative 11 thirds, and you have the positive 1, and you have the x in the middle. So this inequality means that all of the x's fall between a negative 11 thirds and positive 1. Make sure when you're using a compound inequality that both inequality symbols point at the smaller number. So they're both pointing down at negative 11. Otherwise, you have described the empty set. If they were both pointing at the 1, you would have the empty set. So, because, just look. If you had the x in the middle and both inequalities pointing this way, you'd be saying, first of all, the x's that are smaller than negative 11 thirds, okay, like negative 5 or negative 10, but which are larger than 1. Well, there are no x's that are smaller than negative 11 thirds and larger than 1. So both inequality symbols have to be pointing at the smaller value, or else you actually don't have any x's at all in your description. In interval notation, then, we'd say from negative 11 thirds, comma 1, the endpoints of the section that we're talking about.